Hello, this is Robert Casey, and this is a second of 4 topics on Haplogroup projects. This one is creating a YDNA data collection or database with Microsoft Excel. The most part of this presentation will be explaining the need for a spreadsheet as well as actually how to create a spreadsheet. Analysis only using family grouping reports is very difficult, and also a lot of people try to do this by hand or on word processing. And spreadsheets are just a much better match for analysis and keeping track of all the data that you have to keep track of. You need to merge data from other projects into your spreadsheet until they join your Haplogroup project, because half of the people that should belong to your Haplogroup project probably won't belong. Also, YSNP reports are missing YSNP results, especially big Y downstream negative results, which is really key for charting. And you need to filter out massive amounts of junk that's in the primary tree DNA YSNP reports. You also need to consolidate the data. This means you need to take the YSNP testing data and put them in a spreadsheet of the STR data so you can sort both of them and compare for analysis. You also need to consolidate information from other sources, such as testing at Y-Sequence or Full Genomes Corporation, and also Big Tree and YFL are databases of sorts that you can use for input to database as well. You also need to track close matches that are false hits for those and those who are very questionable for prediction, commonly known as boundary condition testers. You need to track them so you don't invite the same people over and over again that have already been looked at once and rejected because they didn't qualify. And also you need to have a list of ones that are questionable of whether they actually may belong to your haplogroup or not. You want to keep them in a separate section. So what are some best practices for YSTR collection? First of all, there are 2 primary ways to acquire data for your spreadsheets. One is you can copy and paste from YSTR reports. And the second one, you can go into the profile of your project members and download a CSV file. Both are about the same. A CSV file takes a little more effort, but not much. Both require you do some normalization from the family tree format to a format that you can analyze better. The first is the multi-copy markers. They have to be separated into separate columns because each of these mutations should be analyzed standalone. Another minor recommendation is to convert the 389-2 to the 389 to in a delta format, because if you don't, the -2 includes the -1 mutations, so you'd be double counting mutations. And the last idea that you have to get a hold of is you got to compress the extra multi-copy markers into compatible standard numbers of markers. These are due to loss of hereditamine, so what we need to do is look for patterns to get them back to where they can be compared to other people in the database. First, there's the passive recruitment. And this is basically where you make an awareness and let people join your project by making people aware. Just creating your haplogroup will enable people to join your project, and so they will do a search and find your project and join your project without any kind of action on your part. The second thing is you can kind of advertise your project on forums like Facebook and Yahoo so people are aware of it. And also you can ask your upstream larger haplogroup projects to create links to your site. And you can also have all kinds of other promotion awareness that helps grow your project membership. There's also proactive recruitment. And proactive recruitment will increase your sample size, which will increase your accuracy and allow you to do better analysis. It's really more of an exercise of getting the best data so you can analyze it in a better fashion. over 75% of your time will probably be spent on data collection. This is not a real glamorous task, but it needs to be done. The recruitment is the most important task because then you have more access to data and you can provide more information to people. Sending emails to surname admins really doesn't work very well because they usually do not have the skills that you're going to have pretty quick, and so you need to send the emails directly to the testers from the YDNA match screens. Also, you need to copy and paste from other projects until you can get your testers to join your project. Also, as you become a project admin for a Haplogroup project, you become painfully aware of the need or the trade-offs between accessibility and privacy. Recruiting new testers to your own project is one form of data collection, and getting them to join relevant other surname projects if you find them is another thing that you can access your surname projects with. You need to recommend project managers enable opt-in to sharing because this data is going to go from your project into your spreadsheet, and technically you cannot really publish this information if it's not public in nature. Also, you need to recommend that project members grant advanced project preference because this allows direct access to VCF and BAM files, and if you can raise funds, you can get use project funds to help enhance your database by doing key upgrades with partial fundings. Also, another thing that's a small thing but it's pretty important is you need to look at opt-in to matching and get it to all levels. There are some people out there that have turned off all the emails, and unbeknownst to them, they've turned off matching at 67, 37 markers, which can be really key to recruiting new members. So what it takes to do a spreadsheet. First of all, you have to purchase or have a copy of Microsoft Excel. You should be happy with purchasing the older version versus getting the rental one. It will work fine. Also, you need to learn some basics. And for genealogy, it's not real rough stuff. You get into some macros, but you can borrow macros from this presentation and other people, so you don't have to reinvent the wheel on the more rougher stuff. Also, it would be better to have a website so you can share your spreadsheet with others. You can get your own website for $110 a month, or you can use free cloud services as well. Here's a little more detail on converting the markers to a standard format. First, you need to get rid of the dashes and separate into separate columns. These are happening to all the multicopy markers, and so when there's dashes, each one of those fields need to be a separate column, so you can do analysis a lot easier. Also, the 389-11 should be reformatted to a 389-2 delta format because for some reason the mutation in the first portion of the 389-1 shows up as a mutation in the second part. So if you don't go to the delta format, you really can't really using the same mutation on two different fields, which obviously will degrade accuracy. You can copy and paste manually and separate the dash format. All you got to do is copy and paste it, and then you swipe a portion and move a section to the right, and then manually update them. It only takes 20 or 30 seconds per person to do that. You can also use macros to do this. The issue with macros is you have to have a standard area to put it in, the standard area where the macro resides, and then you put it in, put all your input into the standard area. It will convert it to the other format, but then you have to do a copy and paste special by values to the final portion. Otherwise, next time you put it in there, it will override what you did before. So there's also special handling for extra copies of multi-copy markers. This is for when like 464 has more than 4. Sometimes it can be 6, 8, 12, even 16 markers. There's a couple ways to do multi-copy markers. You can either put the extra copies far out and use them as uniqueness, or you can try to determine how they got to be that way. If you put them in a normalized position, then these markers become useful. Because if you just copy and paste the bottom 464 markers, those can be very misleading because they really are not representative of what the mutation really represents. So these results are of massive mutational event, and basically all the multi-copy markers can change all at once and make duplicate pairs of markers. These original markers, when they expand, always get copied in pairs. And then over time, these pairs mutate normally, and eventually they mutate back down to the original amount. So if you have 459 that is usually 89, and you have a tester with an A89, obviously the A8 has been duplicated to a pair, and that needs to be converted back to an 89. For a little more complex one like 464, if you know most people are the 13, 14, 15, 17, and you get a 13, 13, 14, 14, 15, 18. Well, obviously the 13 is copied in a pair, the 14, 14 is copied in a pair, the 15 comes across, and the 17 has mutated to an 18. These need to be done manually, and it's pretty rare to do this, but this is the preferred way to do it for accuracy. So the first two things you need to do is you need to have the ID and the YSTRs, okay? Now, do not make these IDs and change them again, because that just makes it useless to other people, for other researchers. You need to use the FTIDs. Also, in the past, we put F in front of it, and it came as a source of inflammatory DNA. And we had Y in front of Y search and some other characters for other vendors which no longer have viable testing. So, yeah, it's still good to leave the F in front of it. But you notice there's some colors on there. Well, these colors don't occur immediately, but you need to highlight them. And there's two ways to highlight them. You can use the, oh, I forgot the name, but it's the conditional formatting. Conditional formatting just really does not work very well, because what happens if you end up inserting and copying all the time, your macros and the values get all messed up. So what I do is I manually go in there and copy and paste and change the colors. That way they're stable, they're put in there, and they don't have any problems when you sort or have an extra blank column for a little bit and it messes everything up. It's just best not to use to hand do the markers. But you have to figure out what the signature is first. But if you have a group, you can look at it, and everything that's a lot of white is obviously not the mutations. For instance, if you look at the second column, obviously the 223s have, the 323s have mutated down, and the 125 is mutated up, and everybody else is 24s. You get into this column, the column with a lot of green in it, which have quite a few 11s, but also has some 12s and even 113. That one's a gray area there, and that might be difficult to come up with a signature for that one. But all the rest of them, it's pretty obvious that what the modal value is, or the most common value. So you need to create just a bare bones spreadsheet with this two pieces of information. You need to add some other basic information. Okay, the most important one to add next is you need to add a column for the surname. Now, the surname is not directly available from family tree DNA. It requires some interpretation. This is what's called a derived field. So usually you take it from the earliest known ancestor. But if that's not completed, it's probably better to put the donor surname other than putting nothing in. The second one is geography. Now the geography usually may be misleading a lot of times, because people with Irish surnames tend to put in Ireland as their, even though they don't have any proof that their ancestors are from Ireland other than their surname. But it does help to know where people are from in Europe or other parts of the world, so you can kind of see the outliers from a geographic point of view. And also another thing that's really necessary is you need to put a very brief summary of your SNPs. But this is in a very special format. This is in a format that's sortable, not alphabetical sortable, but sorted by structure. So what you need to do is you need to create a chain, a very short chain of markers so you can quickly sort things out in your spreadsheet to increase functionality. I do not recommend putting Y500 and Y700 markers into this spreadsheet. It needs to be a second spreadsheet because this is just so massive that it's going to more than double the size of your spreadsheet pretty quick. So here's the spreadsheet with the added fields. Also, you see in the first column that I've color-coded some of the entries. And that's just basically a timeline of who's been added fairly recently. And over time, you can delete some of the older colors. But this is to give you some idea of how new the person is to the project. And then you have the surname. And then if you look at the content of the next column, that's the terminal SNP of the tester currently. And so all that is telling you the lowest positive SNP and a chain of YSNP values that you can easily sort and get some kind of progression of order to the SNPs. Then you have the geography, which is probably not as important as it once was. And as good genealogists, you need to cite your sources. First of all, you need to add a column to say what project the data is found from. So people who have your data, they can at least attempt to find the project that you found it in. And so this is a very, this isn't done enough. It also helps you that when you are trying to update some data, you can go back and look at this project and see if there's any new people there or if any upgrades have been done. So this is key for your own purposes as well. Also, I like to add a column for the source of SNP testing, so you kind of know the characteristics and where it came from. There is the big Y, a summary of it. There's full genomes, which is another source for NGS data. Then there's SNP packs, and you could put a abbreviation for the SNP packs to apply to your particular haplogroup. Then you can put a thing in for individual testing of family YDNA, and we put YSeq in for individual testing of Y sequence. And then if you just don't have any testing at all, but you think they are belong to your project, you can say predicted. One other column, which is pretty optional, but this helps me, is I add a column for the completeness of the YSNP testing. If you're tested down to the very bottom, then it'll be 100% tested. If you're tested and there's like 20 unknown SNPs, then that would probably be 10 or 20%, maybe 30% complete. So this gives you some idea of how complete your testing is for SNP, because once you start, your project gets bigger and bigger, and there's 100 branches, it gets pretty hard to tell, which one is partially completed, which one is fairly completed, and which one is hardly tested at all. And what very few projects have done, and this is probably one of the most key things that you can do, is you need to add some macros for genetic distance and signatures. Once you know the signature, you can create your own macros, and I'll give you examples exactly how they work. And so all you have to do is update your information inside the cells, and then every time you have a new person, you just copy and paste, and it automatically updates. So you only create these macros once, and I give you their bare bones for the macros. So there's 6 macros for each of the YSDR panels up to 100 level markers. And the reason that these have to be fairly separated is because when you copy and paste these are pretty slow to actually calculate. So if you're doing hundreds or thousands of testers, you need to have these macros broken up to 6 different segments. Another macro that there's another macro closer to the front that basically just adds up these 6 macros for a combined value, and it gives you generate distance. Then there's one macro for a signature, and since it's only usually 6 to 12 type markers, it's a pretty easy one to create. It's going to be fairly close to your left side of your spreadsheet. But first, you have to determine the signature of your haplogroup in order to put these macros together. It's not really hard to create a signature, but it takes some thought to get your mind set that this is really a good thing to do. First of all, you should take and only look at people that are confirmed positive and create a temporary column set to 1. And then you sort your spreadsheet of all the people based on that value of 1 to get them to the top. That's the power of a spreadsheet. You can just add a field and then sort it to get everybody of interest. The reason you can do that, you can only determine the signature of people who are actually tested. If you start putting speculated people who you think and they later turn out not to be, you're corrupting your data. And so you should only use actually confirmed people to determine your signature. So you sort it by on 1, and then you add a row. Let's say you're doing something under haplogroup L21. L21 has a very well-defined modal values, and then what you do is you copy and paste that once as a reference. And then you sort and highlight everything. Then you sort and see what is consistently different from the L21 modal, and that will be the signature of your haplogroup. Now, if you're not doing L21, you can, like if you're doing some other one, you can look for some major older haplogroups that are 4,000 to 6,000 years old, and those modal values are usually publicized pretty well. So any marker that has 75% of off-modal values is part of the signature. Anything that's below 75%, you reject it. And that's how you determine a modal, and that's how you determine a signature. Now here's a spreadsheet for BY246. And if you notice in that one first row that's above the rest, that's the modal value of our L21. So that's the starting point. So when you're trying to do the signature, you can just highlight all the ones that don't match. If it goes up in a value by 1, it's a light green. If it goes up in a value by more than 1, it's a dark green. If it goes down by 1, it's in a kind of an orangish brown. If it goes down more than 1, it's a gold color. So what I do is I sort everybody that's positive for BY246. So I got those people separate. Then I color coded them, and it's pretty obvious where the colors are. Now I got rid of a bunch of columns that were very sparse or had very little information in them. But it's pretty obvious the ones that have a consistent colors. So there's a couple things to note. Well, the first 5 are all the same color consistently. But there is one thing on column 3 there. The third portion of that is 15, but the standard value is 11, which is quite different. So you really want on a signature match to say anything greater than equal to 15 is acceptable. So you don't use 12 and higher because that's just not relevant from 12, 13, and 14. All your guys are at 15. But if they go up from 15, that would be acceptable as well. The second thing is if you look at the one that has some orange and gold in it. The orangish brown is closer to the modal of L21, so that's your mutation. But all the gold ones are also satisfy a signature match, so that counts in the 75% count. So basically, you'd write up a macro for a signature match that says everything is greater, less than and equal to 16. So that would catch everything in the column. If you look at 449, the next one across, there's 3 people at 31. That's just probably a small branch off of this particular haplogroup, which will be real important in being able to separate different people from different groups. And the next one is the 481, the 12th marker. That's an interesting one because it has 23s and 24s, which is all good, but then there's a 21. You just should not get real upset. It's going to happen. Sometimes the markers are going to be going against the actual signature. So that 21 would reduce the signature match and would also not match the modal value of 23 as both. It's just a mutation. You get mutations in the signatures just as well as you do get mutations anywhere. So here's the macros for, and the first thing is going to be for the signature. And so if you look in, it's a COUNTIF. A COUNTIF just says if this expression is correct, it's 1. If this expression is not correct, it's a 0. And so it basically looks for matches. And every time it's correct, if all of them match, then you get all the COUNTIFs are 1, and you get a signature match of 100% of your signature. If one's missing, then it'll come back 0 for that one, and then you would get one less than your signature. So if you look at N is 390. So this says basically for 390, anything that's greater than or equal to 25. And P, if you look down below, is 391. Since for P, anything less than 10 is a signature match. And so all you have to do is put in the greater than or less than sign and the number, and you put it in once for your signature and you're done. That's all there is to it. And so what you do from then on is you just copy and paste all these macros, and guess what? It all automatically updates because the only thing it changes is the row number, which is what it's supposed to do. So there's no big modification. If you ever decide later, if you start with a fairly small haplogroup and you say, well, really, I got the haplogroup signature wrong by 1, I want to take 1 out or add 1, then you can go in there and change the values and just copy and paste the whole thing over again, and it'll update everything automatically. So once the macro is created, you just copy and paste. But all macros are just copy and paste any new testers added, so it just automatically updates. So there's nothing to this once you get the actual original macros counted. Now the actual genetic distance works a little bit different. It still has the COUNTIF, but it counts all the markers instead of just the ones in the signature, because you're looking for all the deltas from the signature, including the ones that are not part of the signature, which are still at the L21 modal values for this particular exercise. So what you do is you have a macro to copy and paste all the L21, and then you just go in there and stick in the values of the signature to the actual signature values. Just update those 7 or 8, and then you're done. And so I'm going to give you a quick example of how powerful a signature can be. Because just with that little simple exercise of creating signature and genetic distances, now you can sort on those 2 fields. So the last 2 columns in this output, the first one is signature match, and the second one is genetic distance. And this is sorted. And I sorted this across 54,000 testers for this particular haplogroup. And so what we got is everybody in green is positive, and everybody in purple, or whatever color that is, they're all negative. Now you only look at negatives and positives. You don't look at predicted ones on that. And so what you look at this, and you can do empirical SNP prediction. If you look at the highest signature to test positive is 12. There's 12 markers in this signature, and everybody with 5 or lower have tested positively. At 11, there was only 1 person, and probably later on there could be more. So your signature for SNP prediction could change over time. But 11, everybody for 3 and below match. Then if you look at the other 2 at 11, which are negatives, they're astronomically high genetic distances, so obviously those are not going to be ever counted. And then at 10 you got 2, but they're astronomically high. And then you got one at 9. Somebody at 9 may later test on, and be positive. Who knows? Because you can test positive down to about never below 50%, but sometimes around 60%. So you could get a tester later on at 9 or 4 that could test positive. And it would still fit in because you can say, well, anything at 9 and 4 below tests positive. Everything else is going to test negative. So you can create your own empirical YSNP prediction without any kind of tools other than sorting your signature and genetic distance. This empirical YSNP prediction is incredibly powerful. So currently for BY246, everybody has 12 match for the signature. It has a genetic distance of 5 or less, or if all tested positive. Everybody's signature of 11 and genetic distance of 3. So that's your current prediction model, and it'll work 100% of the time right now. However, this is not a very well tested, not a very large haplogroup database to draw that this is never going to change. So later on, let's say somebody at 12 comes back at 7 genetic distance, and it later tests positive. Well, you'd have to adjust your actual model to say, 12 genetic distance less than 7, less than or equal to 7. And later on, somebody at 10 a genetic distance of 3 could test positive. So this is not a permanent step prediction, and it's a little going to change somewhat over time if you only have 10 or 15 positive testers. Now once you get to 100 or 200 positive testers, it's very unlikely to change, but even then they can occasionally change just a little bit. But this is an empirical model, and it has 100% accurate with current data. This kind of stuff is very powerful, and it works. So this is why it's key to really add the signature and genetic distance macros to your spreadsheet so you can develop your own empirical model of SNP prediction and really know who belongs and who really doesn't. Now you need to be proactive and build your database because increased sample size equals higher accuracy. 75% of your time probably is going to be spent data collection. It's not real glamorous, but it's a realistic thing. That's your purpose, is to build your community of people who have a common goal. You can't do that with a little bit of work to recruit people in and then copy and paste from other projects. Recruitment is probably one of the most important tasks you have because the more data you have, the more you're going to be able to explain what's going on. You can get more people to test or upgrade, but if they're out there already tested, you should work on recruiting because if you throw away half your data, that means you're going to have to get people to test twice as much to make up for it. So sending emails to surveying admins just doesn't work very well, but you can use the YDNA match reports to send emails directly to you. Recruitment is difficult. Many people just do not understand the results and they've just checked out. And so you need to expect less than 50% response. And you need to keep after them, but do not harass them either. I mean, I have a rule that is I never send an email unless it's 6 months apart. And unless there's some real exciting new discovery, then I might contact them more often than that. You need to personalize your recruitment emails to show what you know and what can be learned. You need to do a sales pitch and you do an educational pitch, but not too in-depth, but you need to do enough to get them enticed to want to enjoy your project. You need to send links to your spreadsheet or other documentation you have, so then if they really want to look at those links and see, wow, this looks like it's working. And you need to show step-by-step details on how to join because people just don't know how to join projects without yours. You need to understand the impact of privacy and the loss of access to data, which privacy means. So you need to lobby testers to update their privacy settings. You need to go from disabled to enabled for opt-in to sharing, so that the data that you have in your own spreadsheet from your own project can be shared readily with other people. If everybody's disabled, you really are not supposed to share project members' data unless it's enabled. So it becomes a real issue. Do you have two copies, one with a full data set and one with private? I mean, it just comes too laborious to keep track of all that. So you need to get people to enable as much as possible. S7834 has 40 known testers from the confirmed positive. And you can go to the public family tree, Haplogroup, run the geography report, and it'll come back and tell you how many are known positive. That's good information, because I only know 28 people I could find, yet Family Tree Day says there's 40. So I'm missing 30% of the people who have actually tested positive for this haplogroup. And it's a pretty recent haplogroup. So the ones who have not tested at all, it's probably going to be a lot more than 30%, because people who have SNP tested a lot tend to join projects more because they're down that curve of learning that SNPs are important. So most people are probably going to have 50% of their data missing from their current spreadsheet. So this is probably directly from privacy. Around three and a half years ago, Family Tree Day started defaulting everybody to basically to the current standard of opt-in sharing disabled. So this is going to be a main. You don't need to hard-nose people on it, but you need to always recommend it, and don't do it for them. Just recommend it to them and let them do it, and tell them the advantages of doing it. Also, you need to encourage Big Y testers to submit their VCF files and possibly their band files in the future to Big Tree, to the data warehouse, which feeds the Big Tree, and also to YFull if you're not R1B. Now, one thing that you do when you take on the role of an admin, project members expect help. So this requires the admin skills to be somewhat higher than the testers. You don't want to be the blind leading the blind. So you need to watch some YouTube videos and just get one step ahead of the people so you can, at least give them some guidance. Now, you don't have to be the expert on everything, but it helps to get yourself educated. So when people start asking the common questions, you have no idea what to do, you need to start watching some YouTube videos, and I'll cover that later, some good ones to watch. And then you can, provide assistance. It's really hard to determine the skill level behind people's questions. So you need to state your assumptions and your responses so people will understand this is how you're interpreting the question, and here's what I think the answer is to that particular question. Because if you don't do that, you're going around and around in a circle with, that's not really what I meant. And so once you state your premise, they're going to have to come back and say, well, that's not what I meant. They'll fine-tune their question to something different. Also, always give a brief analysis of the tester, and always give testing recommendations. You'd be surprised how people are looking for any kind of information to what to do next. And probably 50% of the time you give testing recommendations, they'll be followed up within a week or two. So this is a real powerful thing, but you got to have some skills to be able to do proper analysis. But your assistance will make a big difference to these people, because you're basically their support structure, so you need to be able to be one little step ahead of them. You can also take your project to a very high level. If you're very technical and you want to take to this level, this is probably only 5 or 10% of the people will be able to do this. You can actually create macros that automate SNP prediction, and they use the existing macros. For a mere $20, you can buy a product called Acostat, and you can run your data through it, and it'll come back and give you a model, which is a binary logistic regression model, and you'll put the constants in there. The model never changes, but the constants do. And you stick those constants in that macro, and boom, you got prediction that's 100% accurate. And you just go over and look, and it says this guy is 80%, this guy 100, 100, 100, 0, 0, 0. It takes all the guessing out of the game, and it doesn't take 5 or 10 minutes to run prediction to get these models. It's not rough, uh, and there is another video on SNP prediction, both going from the empirical value to an actual mathematical model. Also, genealogies love box descendant charts. And that's all what SAP does. SAP is a charting tool that allows you to put the data in, and it has some input requirements. And then you can produce a box descendant chart of how your whole haplogroup is related to each other. Now, but SAP's accuracy is dependent on how much data you feed into it and what kind of data. You need to filter out the false hits so SAP doesn't try to connect them. So you have to really do SNP prediction, fairly accurately and not include anybody that doesn't belong in there. Otherwise, you're going to have garbage in, garbage out on your charts. So the higher quality and the larger your quality, the more SAP has to work with. So there are two more videos that you can watch. One's called SNP Prediction, and it takes you through the whole procedure of SNP prediction, and it tells you a lot about signatures and how they work as well. And in charting, there's another video in charting, which can give you an idea of the power that's available now and just how much progress we've made in the last year. So here are some good YouTube videos to get you up to speed if you decide to take on the task. First of all, the third presentation in the series for Haplogroup is how binary logistic regression SNP prediction works. This is a pretty heavy-duty description of how it works, but it's understandable if anybody has math background. Also, there is a good presentation on YDNA charting on SAP or doing it manually. And this is my version of what charting. Also, you can get David Vance's presentations, which are really good as well, which will allow you to figure out how SAP works and some of the switches on them. Also, here's an overview of how SNPs are used in surname projects. They're now kind of the standard way of sorting out people by haplogroups so they know which particular branch of the tree they all belong to. People should not be doing it by geography anymore. They need to do it by how they're related to each other, and haplogroups tell them how they're related to each other. Now, not everybody will be assigned to a very recent branch, but some people might end up stuck in real high levels of being predicted for RM269, which is very, very old. But you want to be able to group them by SNPs. This shows you what a surname admin goes through. So if you're thinking about being a surname admin, this is a good presentation for you to watch. Then, if you're really enamored with why the family tree name match reports seem to not work at times, this video shows you why the family tree name YDNA match reports don't work as well as everybody thinks they do. It's because there's some basic math assumptions that family tree makes which just aren't correct. And so this takes you step by step to show you that most people are having 50% false hits versus the 5% being advertised by family tree DNA. But on the good side, you can just ratchet down the genetic distance a little bit and get the false hits dramatically reduced. Also, Maurice Gleason has some good presentation. This is one of the more recent one, and John Cleary gives very good presentations. And you can just go into YouTube and search Genetic Genealogy Ireland, and there are just dozens and dozens. These are by far the world premier presentations and videos on YDNA in the world, bar none.